feature, which is MBTR, that is many body tensor representation. Here also we are getting quite moderate result for formation energy, but the band gap prediction is poorer. Now, why this is happening? Because the sign matrix eigenvalue, they essentially contain the atomic number, the pairwise distances between the atoms, and while MBTR, it additionally contains the information about bond angles and atomic planes, but these features is sufficient for the prediction of formation energy. But for band gap, it is a more complex property, and we need more information on the composition. Thus, we have chosen the magpie features, which encode the compositional features, and it captures the ionic features like electronegativity, the electronic features like the number of valence electrons, and features like atomic number, the group number, etc. So we have worked with these 13 particular magpie elements, and for each element it generates another 4 terms. Thus, we have total 52 number of features, and this is the feature importance with Magpie. Here we have 52 columns. So we have tried to summarize it a little bit. And here I have combined the mean, average, those parts for each single element into like one column I have given. And so we can see that the most prominent features are like group numbers, the valence electrons, the electronegativity, etc. And this heat map shows the correlation between those 13 combined features. Now, using this magpie feature, as we run our random forest model, here we see that compared to our other previous slide, the band gap prediction is better. Now we have done formation energy prediction also, and it is also quite good. So after that, we did some trials and errors using the cross validation. Now, cross validation is important for the performance, for the reliable performance estimate. It helps in terms of hyperparameter tuning, and it prevents the overfitting and underfitting. So first we did with cross validation like CV equal to 5, and then we performed with CV equal to 10. But if we compare these two results, the result has not changed much. So, what is the problem or what is happening? Now, there can be problems coming from like our data set might be too small, or the model is too simple, that is it underfits it, or maybe it is too complex so that it overfits it, or our featureization needs to be improved, or it may also be that the model is already well fitted. So this part up to is using the random forest. In After that, what we performed is we tried with another model, which is K nearest neighbor models. We have used the K value as 3, so that so in this model, it calculate for a particular point, it calculates the distance between distance with the other points, and for its 3 nearest neighbors, it I mean, comparing with the properties of its 3 nearest neighbors, it gives us the result. And but here for me, both the formation energy and the band gap, the R square value, that is decreased. Now, this may happen because the the random forest, it handles dimensionality better than the k nearest neighbor. And the k nearest neighbor model is more sensitive to noise compared to the random forest. So for our work, we found out that random forest is working better. And also we found out that with random forest, the prediction speed is faster, and it also less memory is required. So for our project outcomes, firstly, we have learned like the basics of machine learning. Also, we have worked with three feature descriptors, which are sign matrix, MBTR, and MACPie. And we have implemented two machine learning models, which are random forest and k nearest neighbor. Both the model can predict the formation energy well. We have got the value of R square above 0.8. But the prediction of band gap still needs improvement. Although using random forest and magpie features, we have found it around 0.7, but it still can be better. So here is our here might be our scopes of improvement and future guidelines. We may work in this direction, like our choice of data set, it can be larger. We can consider hybrid descriptors because for sign matrix and MBTR, we were only considering the structural features, but and for magpie there is compositional features, so we can combine both of them and make a hybrid descriptor. The exact dependency of the output on each feature vector, I mean, if I am considering the output as y and the input as x, then how the y is dependent on x, that we can find out. Another thing that could have been done, like we can increase the number and depth of the random forest trees, and we can test with other machine learning models, and we can extend these models for the property prediction of unknown compounds. So that is all we have done, and we have taken help from the class notes and hugely on from internet. And thank you for listening.
Uh, Shubhakar, would you like to ask some questions?
Yeah. So I think yeah, some of my questions what I wanted to ask they have put in future. So one basically random forest I thought like they would try multiple trees, and Canaan they could have tried with multiple Ks just to check the how much those hyperparameters were affecting the model itself.
Sir, I have
And so
tried.
that you have tried already?
So yes,
Sir, actually, my results are not in the PPT, but I can show in the code. Or
Yes, that would be wonderful. Yes.
I think we are in the present mode.
Yes,
I
yes,
can see
yes,
your
yes.
screen. Yes.
So actually, I have tried using 2K value, CV equals to 10 and 5.
Okay.
It's my code.
Okay. Yeah, so this is nice. So generally this grid search is preferred. So at least you should try variations of all these parameters to find out what actually works. And number of estimators 300, 500. Okay. Probably this could have been expanded a little bit more, maybe, in my sense. You could have tried till let's say 1,000 trees or something. Okay, so my then I will just have maybe one question on the so like why random forest and why KNN, let's say. So like what was the choice or motivation behind, picking random forest per se?
Sir, for random
Oh,
forest, we
yes.
have used the regressor model because it is I mean we need particular values. I mean it is not an like yes no type thing. So we need a particular regressor value. So we thought that random forest could be great because here we can also vary like the depth of the trees, the number of estimators, number of trees. So we could have played around a lot. So uh,
For
Okay.
smaller data
So
sets,
then, yeah, please go ahead.
sir, I'm saying that for small
There
You got
is
muted,
minor connection.
Lagna, you got muted.
yes, sir. Sir, are you asking me or Shubhankar the?
You are on the same mic, right? So your mic got muted.
Uh,
Yeah.
can you
So
see that? Can you hear that?
Shubhankar was saying something. Please go ahead.
So for smaller data sets like 2522, uh, uh, we are trying to random forest because we can make various tree and collect the data and average.
Okay, so let me ask one question each, huh? So Sulagna and then Shubhankar each. So like for example here, like random forest is part of ensemble, right?
Yes, yes.
So then this question goes to Sulagna per se. So random forest, like what are the like how does random forest target, let's say, the variance and bias? If you can just tell, if yeah. Is the question okay? I can explain more if there is
yes,
a
sir.
issue with the question.
Explain. Please explain.
Huh. So like generally this ensemble methods we so originally what happened? So either we have models which have either super low bias, but they will have very high variance,
Yes.
or we can have models that have very high bias but then very low variance, let's say. But matlab, very low bias and very high variance. So we are typically looking towards low bias and low variance. Hmm.
Yes.
So this question is particularly to Sulagna. Then I will ask one more question to, let's say, Shubhankar for this one. So like what are the things that are present in, let's say, random forest per se, which basically help us in avoiding this situation
Very
of
good.
either low bias, high variance, or high bias, low variance, and moving towards more stable low variance, low bias.
Uh,
Like what are the
sir,
features in random forest that are there?
sir, can it be controlled through using cross validation? Because when we are using with the new like CV, the whole data
Mm-hmm.
set is trained only once. But as
Yes.
we are using split, CV split, it
Mm-hmm.
divides the data set into five and it trains each one individually. So can it be
Yes, you
done
are
through that?
almost there. You are like almost there. Matlab, it's not part of the CV, rather it is part of the random forest bootstrapping itself, right? So whenever you
Uh,
create new bagging, yes. So that
yes,
is
sir.
one.
So
And
so
another
I
thing,
remember that
yes.
it asks like 100 times 100 persons a question and then it takes the output like averaging out all of those from those 100 persons.
Yes. So
Yes.
this is specifically the number of estimators that you have, the 300,
Yes.
500, the 1000. These are specifically for every tree you are creating a new data set from the
Yes,
main data set only. So,
yes.
but that new data set that you create from the main data set, basically it's, how do I say, it's by like sampled with replacement. So you get like some variations in the data set itself. Hmm. So the model is not learning only the particular data set that you have. So more the number of trees, the more you ask basically random forest to be more, how do I say, unbiased, let's say. Hmm. Okay, do you remember any one more thing that was there in the random forest that helps in this bias variance thing?
So alpha learning rate.
Learning rate, no, not in matlab, okay, matlab, learning rate is a more vague term that might
Okay,
answer.
okay.
Okay, fine. The other thing, anyways, we're discussing. So the other thing was
So the
specifically
minimum
that,
sample split, can it help? Because like even if like I mean two samples are there, it splits the node. So
hmm.
can it help in that regard?
So minimum sample split probably I think is basically the one that designs what is the depth of the tree.
Uh, yes, and
Hmm.
you are asking more number of questions. Like even if there is two samples, you can go this way or that way. So
Correct,
can it
correct.
help to like generate
Yes,
more variation in your
yes,
data?
that is one area it definitely help. But random forest specifically has this, you remember, I think we discussed like the features are sampled.
Yes,
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 Like
yes,
not
yes.
every time the
yes,
entire features are taken, some k
yes,
random
yes,
number
yes,
of features are
The
taken.
parameter
yes, yes,
max
Yes.
yes,
samples.
max, yes,
So
yes,
Max
max
samples.
samples, I don't know. It's like from the features. Yes, yeah. So that is one. Okay,
best
so the
feature is
next
this,
question.
best
Yeah.
parameter.
So the next, yes, yes. Stick. So then the next question to Shubhankar, because we have this random forest, the other partner to it is boosting. Do you remember anything about it, Shubhankar?
So can you tell the question again? I did not hear properly.
So we discussed in ensemble, generally we discussed two types. One of them was, let's say, the bagging, let's say we have this random forest is one part of it. The other ensemble learning was the boosting. Hmm.
Yeah.
Do you remember anything about the boosting?
Uh, I forgot.
Oh, no problem. Okay, so then let's ask on KNN. So like current KNN that you have implemented. So for example, like how can I select a good value of K? Like for example, if I go ahead and like I have to select some value of K. For example, you in your project selected 3. Like the question is why 3? Why not anything else? Or how did I know that 3 was really good?
Uh,
Mhm. What is the easiest way to know that if 3 is good or not? Or 3 is good, or
uh,
2 is good, or 4 is good?
so I don't know actually.
The easier answer is I can just try all of them and whichever scores better.
So
Yeah.
that
Yeah.
actually we can say, but I don't know actually more deeper. So that's why I say I don't know. So I
Yeah.
can try
No, I was
and I
asking.
can tell.
Yeah, so nice one is. So the other ones we have discussed a few things, I think elbow and those checking from validation. So for example, you don't have to even touch testing because once you touch testing, then you know about test data. So there was one more thing you remember, like for example, I showed a figure where you could break into like training and validation. So you run the KNN on the training and then you again run it on validation and then you run it on both training and validation. So if the validation or let's say the validation class, whichever the data points belonging to validation class, if they belong to the same cluster in the when the KNN was trained on the entire data set, as well as trained on training and then tested on validation. So that was one way to find out which K will be better without looking at testing. But okay, I'm good. I'm good. Precision, I'm good. Yeah.
Okay, so maybe I'll ask a couple of questions on the materials aspect of it. Uh, can you go back? Can you bring up the slides once again, please?
Yes, sir.
And you had a slide where you showed importance of various features in the random forest, magpie features. Yes, these two slides, 13 and 14. Let's go to 14. Next one. Yeah. So, right. Um, so this is a question for Shubhankar. Can you try to rationalize why these features and say group number is comes out. I'm not asking why it comes out with the highest importance, but why it you think it would have a much higher importance than say number of uh, ace valence electrons. That is my first question. In other words, does it look consistent with what you would think in terms of your physics or chemistry knowledge?
Yes. So, we are uh, uh, try to get the best formation energy and band gap. So the to get the best formation energy, there are interactions uh, interactions involved between the atoms. So group number is the more
Uh, one second. Is this importance for formation energy or is it for band gap?
okay.
Say it is for band gap.
Yes.
Yeah. So actually, essentially, valence s electrons does not have any importance or any doesn't have any on a role in the interactions to calculate the band gap or formation energy. I can say actually the interactions involved. So in the interactions, the valence s electron had no role actually.
No, what I'm asking is not so much for you to interpret these observations, but what I'm asking is I noticed two facts. Let's say that group number has a lot higher importance in determining band gap compared to say number of ace valence electrons. Is this consistent with your knowledge of physics or chemistry of materials? If yes, can you explain? If not, can you explain the contradiction? So, what would be your answer?
Obviously, yes. Obviously, yes. This is the consistent with the chemistry or physics, and why? Because like uh, NaCl and so if I the the like properties, or we can say
Yes.
like NaCl form uh, ionic crystal,
Uh-huh.
and some other compound may form like covalent type. It is depend on the group number, when which groups they are, from which group they are forming. So there is the dependency of the group.
All right. So I'll leave it at that point. Yeah, can we just go back a few slides? I just want to check what else um, you had. Yeah, right. So, Shulagna, what is the size of the sign matrix that you had?
Say 10, 10 by 10.
10 by 10. And when you use sign matrix as a feature, what is your feature space size, dimensionality?
Say, it was around 45, 40, say 40.
Yeah, can you explain that number 40? So you are only using sign matrix, right?
Yes, sir. Sir, because when we downloaded the data, we specified that the maximum number of atoms that should be between 5 and 40. So the sign matrix can have maximum 40 rows or 40 columns. But in this particular structure, there is 10 atoms within one unit cell. So for this is a 10 by 10. And then we found out the eigenvalues of the sign matrix. So what happened is that, so other than the last few rows, the others were 0.
Yeah, so my question is, so when you use sign matrix or eigenvalues of the sign matrix, whatever you use, it has to have a constant length for all materials in your data set, right?
Yes.
So what is that size?
Say 40 for yes, 40.
Okay, so that was the number of maximum number of atoms in your unit cell.
Yes. Yes, sir.
Now, suppose instead of using the eigenvalues, you were using the matrix elements of the sign matrix as your feature. Okay,
Yes, sir.
what would be the dimension of your feature space?
So 40 into 2 number of compound.
Uh,
No, notice that you have to have a feature of a constant length for all materials. So if you have a maximum of 40 atoms in the unit cell in your data set, and you are using sign matrix as your feature, what would be the length of your feature vector?
sir, I cannot like downgrade this unit cell, but I can take like 5 more add like take a supercell from it. So I will take a supercell of it and create like make it 40. Then everything will have a 40 dimensional. I mean, a size of
No,
40.
no, that is not my question. Firstly, what you said is not what you do. You don't create supercells. We have discussed this thing in the class. You remember that you simply zero pad. If a certain material has less than 40 atoms in the unit cell, you pad your sign matrix with zeros and make it 40 by 40. You fix your size, which is equal to the size of the largest supercell. Largest in the sense maximum number of atoms. So that in your case is fixed to 40. Now my question is, if that number is 40 and you are using elements of the sign matrix rather than its eigenvalues as your feature, what would be the dimension of your feature space? Well, I can give you a small clue if that helps you. See if you can. So the clue is that sign matrix is a real symmetric matrix. So now can you tell me how many So what will be the length of your feature vector?
So,
Symmetric tensor,
Sorry?
number of compound cross number of compound.
See, you have a 40 by 40 matrix, which is real and symmetric. So your feature space dimension is simply the number of independent matrix elements, right? And in a real symmetric matrix of any size, you know, if you have an n by n real symmetric matrix, what is the number of independent elements there? That's your answer, right?
it's
If
A
your
into
feature
n minus 1. I mean, I can only take the like the diagonal elements and like one from one end of the diagonal, because
yeah,
the other end will be similar to it.
so there's no
So it
point
will be
taking both. I mean,
the
the
yes, sir.
matrix, you just take one half of it.
So
Diagonal.
it will be like 40 into 40 minus 1 by 2.
I think it is 40 into 41 by 2, not 40.
Yes.
Aiming to n plus 1 by 2. Okay, so I think, yeah, that's all I would like to ask.
Sir, regarding your other question,
Mhm.
sir, sir, here the valence, sir, it is a perovskite compound. So
Mhm.
oxygen is always present, and
Mhm.
oxygen has like p electrons. So the s or f electrons will not have any impact, and there is valence p electrons. And in case of but the p electrons, it is almost present in all of the compound. So maybe because of that, the group number of the like it is AbO3. So
Mhm.
other than oxygen, there is Ab, and depending on the A or B, it depends on the group number. So maybe for that reason, the group number might come at one of the more prominent positions.
Right. I think that brings in, so the difference. So when you say group number, now this is, I'm not asking this question as a curiosity rather than as an exam question. So when you say group, your magpie features, can you go to the your slide number 12?
Yes, sir.
Yes. So if I look at group number, so you are taking the mean, the range, mode, average, deviation of the group number, right? So
Yes,
any
sir.
quantity you are constructing these four sort of statistical functions out of that and using those as your features. Now, when you
Yes.
say group number has the largest importance, what of group number? Is the mean group number, range of group number, mode, which one?
Um,
Mean.
so it is the
It's a
mean
mean.
of the group number. I mean, we have plotted it like individually also.
Mhm. What I would expect is that if you could plot the sort of difference in group number, or maybe standard deviation of the group number, or the group maximum deviation of the group number between the three elements, or oxygen is common, so A and B, that would probably, if that has the highest importance, I understand it, because the larger the difference in group number, you see, the larger is sort of the ionicity in the bonding in the system. And ionic, the larger the ionic sort of percentage of ionicity in the bonding, you tend to have larger band gaps. So that is how I was trying to understand it.
Okay, sir.
Okay, so I
Okay,
have a quick
so
one.
that's okay.
Roshan, I'll just ask a
Yeah, yeah,
quick one here. Yeah.
yeah.
So, like here, when you say feature importance, as in like Okay, so generally, this was done very early, but like feature importance in relation to what task? So generally, what we saw, let's say you have 4 features, but one of the feature might matter for band gap and the other feature might matter for some other property. So when you
Yes, sir.
talk about feature importance here, what does it mean? Like as in it's just
Uh,
variance?
Sir, we perform this feature importance for both of them, both the formation energy and the band gap part. So this part is for the band gap.
Okay, but is just the variation, like the variance in the both the cases, is that the how you target importance, or there is some other?
As we have understood it which compositional feature is mostly controlling our output. So is it like that?
Okay,
Because of I mean, the prediction is mostly dependent on this group number.
That means actually
Hmm.
variance.
Hmm. Yeah,
No,
so
so which function of the group numbers? Is it the mean or the variance?
So it is showing here mean.
Oh, it is okay.
yeah, if I zoom in,
Yes, it is.
bigger, it's showing
Yes,
mean.
sir.
Yeah,
Yeah. Okay.
yeah,
Uh,
fine, fine. So yeah, okay, this is fine. So generally, what happens is earlier people used to do it when there was no compute. But for you, what you can do is probably run through the model itself and it will give you importance. Or is it after running the models you have found out this?
So after running the models, we have found out this.
Okay,
I mean,
okay,
we
okay.
have
Then
not put
then
it by ourselves. This is given by the
mm,
model.
mm.
Based on
Acha, okay, okay.
Yes.
So initially I thought probably you had variance mapped and whichever showed had variance in compared, like it's finding covariance between band gap and this. But that is not this case.
No, sir.
Okay, okay, okay. Fine, fine. I'm done. Yeah,
Yeah, it's fine. Uh, I don't have any other questions. Um, all right. Thank you. Very nice,
yeah,
Shulagna and Shavankar. You put in some effort. Uh,
yeah. Hopefully,
so
and you
we'll have
can try
the
anything that
exam.
is. Sorry, Professor Sen. I was
Yeah,
just saying
sorry.
that they should
Go
try
ahead.
the
Go ahead.
future work. Yeah. And I'm like, whatever they have
Yes.
mentioned in future work must be tried. Matlab, that's a minimum thing to complete the work. I hope you both do. Yeah. Hmm. Yeah, I'm done. Sorry.
Yes, sir. We will try
Yeah.
to do that. Uh,
Okay. Okay.
Just one more question. I mean, again, it's not an, it's not about the exam, but it's. I just wanted to know. So, where did you run your this machine learning course?
so I did it using my laptop, in my home,
Mm,
and
and I did in this computer.
like, our normal computers, home computers.
okay.
This is.
Okay. Yeah. Fine.
Yeah. Okay.
Okay. That's all for today then.
Exam on Monday. Yeah.
Yes, sir.
Yeah. And
Yes.
you can write to us about your feedback definitely.
Okay, sir.
All right.
Okay. Bye.
Okay, sir.
Bye.
Yeah. Bye. Bye.